DNA replication. How does DNA replication work? Here, I'm going to show you. Here we have a strand of DNA that's about to be replicated. It's normal, nothing fancy about it, just base pairs, A to T, C to G, T to A, and vice versa. Alright, so first, helicase, this little green structure right here, is going to unzip the parental double helix. It's what I showed you right here. Alright, next, right here, this little pink glob is called DNA polymerase 3. Alright, and DNA polymerase 3 is going to synthesize in the 5' to 3' direction. So you see right here, the top strand right here is called the leading strand. Now, the reason it's called a leading strand is because it goes from 5' all the way to 3' over there. This, and it's fairly simple, right? It's just going to be DNA polymerase 3, DNA polymerase 3 is just going to continually travel down the 5' to 3' direction. So it's going to keep going. It's going to go that way. And it's just going to go ahead and start just synthesizing all of them. So it's basically connecting up all the base pairs. So A to C, C to G, it's going to continually finish up the strand. Simple, right? But what about right here, the bottom one? That is called the lagging strand. It's a little bit more complicated. You see, the lagging strand is 3' to 5', and it's basically the opposite of the top. And DNA polymerase 3 can't do the same thing because it's in a different direction. So what ends up happening is primase joins RNA nucleotides into the primer, into a primer, my bad. So right here, this little red glob right here, this is RNA. And this is basically going to serve as like the template, the start point, just something to get the DNA polymerase 3 started. Now, DNA polymerase 3 is going to, once it sees where the primer is, it's going to start adding DNA nucleotides. So, see this little blue strand right here? It's going to, start, kick off the coding. And once it does that, this entire thing right here is called the Okazaki fragment. Now, DNA polymerase 3 is going to continually code up, just continue coding until it reaches another RNA primer. So let's just say right here, there's another RNA primer. It would stop right there, and this right here would be the Okazaki fragment. Alright. DNA polymerase 3 would continue doing this multiple times until it caught up to the original, like not the right here. It would until it would catch up. Until it would catch up to like right here. Fix that. Oop, bad arrow, but see what my point is. It's just gonna keep on coding until it reaches the original strand where it wasn't sliced up by helicase. So it would stop like right there. Now, you're probably wondering that it's not the same as the leading strand. The lagging strand has all these bunch of RNA molecules or nucleotides. How could it be the same as the leading strand? So what happens is once the DNA polymerase has completed the strand, essentially, DNA polymerase 1 will go through the lagging strand and fix wherever RNA was and replace it with DNA nucleotides, completing the DNA strand, making it similar to the leading strand. Yeah. So leading strand, remember, is up top. Lagging strand and now they're the same thanks to DNA polymerase 1, and that is essentially how DNA replication occurs. Thanks for watching.